microplastics are no longer only an ocean problem. They have entered rivers, reservoirs, treatment plants, and the distribution systems that deliver drinking water directly into our homes. Invisible to the naked eye, these particles travel through the same pipelines that we trust for our daily water supply. Every glass of tap water has a story. For environmental engineers, the critical question is no longer whether microplastics exist in urban water systems, but how they move through them. Understanding these pathways is the first step toward removing them. Most microplastics begin their journey on land. They originate from synthetic textile fibers released during washing, tire wear particles from roads, fragmented packaging waste, industrial microbeds, and pellets. Rainfall transports these particles into stormwater systems. Wastewater carries them from households into treatment plants. Even before water reaches a drinking water facility, it already contains microscopic plastic. This makes microplastics a distributed pollution problem, not a single point source. Conventional water treatment plants were not originally designed to remove microplastics, yet many of their processes unintentionally act as partial barriers. Coagulation and flocculation cause particles to bind together and settle. Sand filtration captures larger fragments. Membrane systems can remove smaller ones, but removal efficiency varies widely depending on particle size, shape, and density. The smallest microplastics, and especially nanoplastics, can pass through multiple treatment stages, which means the distribution network becomes the next critical environment. Once water leaves the treatment plant, it enters a complex distribution system that may extend for hundreds of kilometers. Inside these pipes, flow velocity changes, pressure fluctuates, sediments accumulate and resuspend. Microplastics interact with these dynamics. They can attach to biofilms, settle in low-flow zones, be released again during pressure variations. This means that water quality at the treatment plant is not always identical to water quality at the tap. The network itself becomes a reactive environment. Urban plumbing does not only transport microplastics, in some cases it can generate them. Polymeric pipe materials such as PVC and HDPE may release microscopic particles over time due to mechanical stress. Thermal expansion. Chemical interactions with disinfectants. Although these contributions are relatively small, they demonstrate an important principle. Water distribution systems are not passive. They are active environments that influence water quality. Inside every distribution pipe, a thin biological layer forms along the walls. This biofilm acts like a living filter. Microplastics can become trapped within it or released back into the flow when hydraulic conditions change. Maintenance operations, pressure surges, or sudden demand increases can mobilize these stored particles. This explains why microplastic concentrations can fluctuate over time at the same tap. The system is dynamic, not static. The final stage of the journey happens inside the building. Here, water encounters smaller diameter pipes. longer stagnation periods, higher temperature variations. These conditions influence particle behavior and potential release from internal plumbing materials. In high-rise buildings, additional pumping and storage systems add another layer of hydraulic complexity. By the time water reaches the glass, it has passed through a multi-scale engineered environment, each stage affecting microplastic presence. If microplastics entered drinking water only at the source, the solution would be simple: improve treatment. But the reality is more complex. They move through multiple pathways, watersheds, treatment facilities, distribution networks, building plumbing. This means effective removal strategies must also be point of views, filtration, pipe material innovation, advanced treatment upgrades, real-time monitoring. Environmental engineering is not just about removing particles, but it is about understanding the entire system in which they travel. To remove microplastics from our water, we must first understand the path they take to reach us.